Okay, next we'll be working on the triangle inequality theorems, inequalities in one triangle and triangle inequality and the hinge theorem. And so the big deal here is that you need to remember, especially like theorem number 1, that the sum of the lengths of any two sides of a triangle must be greater than the third side. And this must hold true for all three different possibilities. So you have to check them. If one of them is not true, then it's not a triangle. In theorem number 2, you can order the pairs, and we did some work with that. You can order things up based on, if you know like the side lengths, you can order up the angles, and if you know the angles, you can order up the side lengths. So it's always going to be, you know, in order of greatness. The last theorem, and I don't think we talked about this one all that much, but the measure of the exterior angle of a triangle is always going to be greater than the non-adjacent interior angles. So in this case, angle 1 has got to be greater than the sum of angles than either one of these two. And then the hinge theorem basically says that if you have two triangles that have two sets of congruent sides, the larger included angle will have the longer third side, and that's actually going to come up in our very first sample question for this section. So we basically know that the measure of angle BAC is 29, and the measure of angle EDF is 32. So what that tells me is that EF has got to be bigger than BC. And the reason why is because the distance away is the same. These distances are the same, and therefore if the angles are, one is larger than the other, then that makes this one bigger than the other. So based on that information, you have to determine from this list of choices which is true. Is it true that BC is greater than EF? We would say no. Is it true that BC is smaller than EF? Well, we just decided that, but always go back and check the other two choices to make sure. Is it true that AC is greater than DE? We don't know. Can't say that for sure. AC greater than DF. And that's definitely not true because it says in the givens that it's not true. So I'm confident then that my answer would be answer choice B. All right, and now for sample question number 2. We are going to, it's going to form a triangle that's told in our problem here, and they want to know which one could be the length in meters of section or segment SB. So you could call that segment XB. We don't know what it is, so we can call it X. But we would check each of our pairs to make sure that that inequality theorem holds true. So basically that would mean that 6 plus x would have to be greater than 11. Or if I solved it, x has to be greater than 5. That's just one possibility. So I know that it can't equal 5 because it's got to be bigger than 5. So that helps me eliminate a choice. I could also say that 6 plus 11 has to be greater than x. So in other words, 17 has to be greater than x, or I could switch it around, x has to be less than 17. So that definitely helps me rule out these two answer choices because those don't work either. But let's just say that x was equal to 8. Check all three possibilities. Is 6 plus 8 greater than 11? Yes. Is 8 plus 11 greater than 6? Yes. Is 11 plus 6 greater than 8? And the answer is yes. So all three cases hold true, so then my answer is definitely B, 18, or 8, sorry. Okay, next we're going to move into our special right triangles, and Glowworm knows all about these. These are the ones that she likes to use a star for, and that's a great strategy instead of using X because it can get confusing about which X are you talking about. We also have the problems that are like these, and there's two cases for these. And I wrote them up like this because I couldn't draw on the picture when I was doing the creating the document for you. But this first case, case number 1, let me grab a pen, 1, is where you're given the altitude as a part of the problem. And let's just say that this were little a and little b. Then what that means is that you are using x as your mean, and each little part of the hypotenuse is the other pieces. And then number 2 would be, let me move up. Okay, number 2, the second situation would be when you're given one of the legs. Technical difficulty. Let's say that we're given one of the legs as part of the problem, and then this is still little a and little b. Then if you're given that leg, that's going to be your proportional, or your mean rather, and then the adjacent side, which is the one next to it, is the b, and then the other piece is the sum of the parts. So that's one way you can be given a leg. Now let's say we were given the other leg. If we were given the other leg as a part of the problem, then that would be my mean. And then now the adjacent side to it would be A, and then it would be the sum of the parts on the other side. So I tried to write it up for you, but I didn't know if it would make a lot of sense, so I wanted to make sure that I explained that some more. So, sample question number 1 is one in which we are given or asked about the altitude, and that's going to be right here. So now I know I have the altitude as my mean, and the little parts are what's going to be the other pieces. So I cross multiply, and then I take the square root, and x is equal to the square root of 3. So that would be answer choice C. Okay, in sample question number 2, we are looking for x, which is that long length over on the other side. We are given a leg. Actually, I misspoke. We are not this is not one of those special things because I'm missing this being a right angle. So that's not true. So I'm not going to think of it like I just thought of the last problem. But I can think of it like I could find x using Pythagorean theorem. I have the hypotenuse, but I'm missing one of those legs. So I think that we can find the leg, let's call it y to keep it differentiated from our x, by using special right triangles. And so you have special right triangles are on your reference sheet, but the 30, 60, 90 special right triangle is the one that is where the hypotenuse is 2 star. The leg opposite the 30 degrees is just your star if you're using the stars, and then the leg opposite this 60 degree angle is going to be star square roots of 3. So use the star if it helps you. What I know in this problem is that my y is my star when I set it up this way. My 5 is opposite my 60 degree angle, so 5 is the star square roots of 3. So I can figure out what star is by dividing both sides by the square root of 3. And then if I rationalize the denominator, I get 5 square roots of 3 over 3. That's my value for y. Now I have that right triangle, and I can use Pythagorean theorem to figure out what that remaining leg is. So I'm going to be taking that piece, goes in up here for that leg, and so it's going to be leg squared plus the other leg squared equals hypotenuse squared. So 5 square roots of 3 over 3 squared plus x squared equals the hypotenuse squared. Now to square this, and this, guys, I'll be honest with you, this is asking for it in the nearest tenth. So if you want to change that to a decimal, why don't I just go ahead and do that, because I think otherwise you'll get bogged down in the algebra of it. If you wanted to, 5 square roots of 3 squared is 25 times 3, because those square roots will cancel each other out. So 25 times 3 is 75, and then that's divided by 9 because you square both the numerator and the denominator. But let me go ahead and change it to a decimal. So oh, I need my scientific calculator. So rotate function on my calculator is not working. I don't know. Okay, so I'm back. I had to go and find on Google how to unlock my screen rotation on my cell phone so I could calculate the square root of 3. The square root of 3 times 5 is divided by 3 is 2.89. So we'll use 2.89 squared plus x squared equals 144. And then I'm going to square this, and I get 8.3 repeating. So 144 minus 8.3 is 135, and then I square root that, and I get x equals 11.6. So that is my answer finally. But what I did to get the inside here, this number, in the calculator, I did 5 square root of 3 divided by 3, as I believe how you'll do it on your scientific calculator. I had to do it backwards because I was using my iPhone. But yeah, you'll just do 5 square root of 3, hit enter, and then divide by 3.